So I'm going to do two examples of the root test for series. So I'm going to do these two examples, and so just to remind you really quickly, so this is the root test for series. So what we're going to do is we're going to take whatever our series is, we're going to take the nth root of it, and we're going to compute the limit. So starting with the first one, so I've got this 5 to the n over 4n to the n. So okay, let's just set up kind of the calculation here. So this is 5 to the n over 4n to the n. So the way that the nth root is going to work is that it's just going to actually cancel out both of these exponents. So this will just become 5 over 4n. So this is actually like the perfect scenario for your root test, in that like it's pretty simple to like simplify this particular type of problem. And so then once I figure that out, and then I take the limit as n approaches infinity of 5 over 4n, and so that just equals 0, which is less than 1. And according to the root test, if this value is less than 1, then we can say that the series converges. So I'll say it right here, converges absolutely. Okay, now a lot of times you are not so lucky to have the exponent just cancel out so nicely. So in the next example, so now I've got this negative 1 to the n times 1 minus 1 over n to the n squared. So let's just go ahead and set this up. So I'm taking the absolute value. So that will allow me to not worry about this negative 1. That's the point of having that absolute value. Okay, so I've got this. Let's see, actually I'll go like this to the n squared. Okay. So when I take the nth root of this, so in case this like confuses you, so this will be another way to write this, I guess, would be n squared over n. So these are equivalents of one another. If you forgot how like rational exponents work, I do have a review video on that. Okay, so this allows me then to rewrite this as 1 over 1 minus n to just the n. So then if I take the limit as n approaches infinity. Now, there's a few different ways of how to do this, but in our class, we've talked about a few like common limits. So this is actually one of the common limits where my x in this case is equal to 1. So the value of this limit will just be e to the 1, or just e. Okay, now e is greater than 1. And so when the value of the limit is greater than 1, that means that the series diverges. So I can say then that this diverges. Okay, and so that's the end of that video. So thank you so much for watching. I'll catch you guys in another one.